Hello, welcome back to a video lecture about Java object-oriented programming and data structures. Today we will start with chapter 2 about class basics. So chapter 2 is about the basics of the class. So in this chapter, the topics that we are going to discuss are listed as following. So we will discuss how to define a class, how to write the class constructors, how to write accessor and mutator method in a class, and how to utilize the keyword this to refer the object itself, and how to write some other types of instance method. And lastly, we will do a case study about a class definition for a point2D class using reverse engineering method. So the first section in this class is about the concept of class. So what is a class? Previously, if you recall, we learned in any programming language, okay, so it's all about computing, about data. But data has a type. So there are various data type. And in chapter 1, we discussed there are basically two different data type. So primitive data type and object data type. So primitive type like integer, double, char, etc. Okay, they're primitive type. And object type, so far we learned like a string and array. Okay. So so what is a class? So the definition is it's some user-defined data type. Okay. So user-defined type, so the concept is it's like a blueprint for a category of objects. Okay, and this category of object all share common attributes, or we will learn, okay, we call them data members, and behaviors, or we will call them like member methods. So a class is serves like a blueprint to group a category of objects together. Okay, so it's not the physical real objects, just a blueprint. Okay, so a class has two parts. We call them attributes parts. Attribute, basically, we will reflect them in Java programming language as instance variables. And later on, we will not just, because we also have like a static variable, okay, and the static method definition for the class. And there's another part is behaviors. Okay, so behaviors, they are methods, okay, methods, so variables and methods. And later on, we will also say basically the behaviors or methods, these serve as interface to access the attributes or data members. Okay, to access. So this is a very conceptual definition for class. So in Java programming language, the syntax to define a class, just very general speaking, okay, you need to provide the scope, the access scope of the class. So it's public or private, okay. And generally speaking, and then following by the keyword class. And this is the name of the class you're going to give your class, okay. So this is the general, and for the public, you can also define it as private, okay. So this is the scope, access scope of the class. And within it, a class, previously we said there are two parts, attributes and behaviors. Okay. Attributes reflect as instance variables, and behaviors reflect as instance methods. And generally, when we define instance variables or attributes, we let its access scope as private. Okay, so because anyway it's variable, so you also need to give it a type, like is it an integer or string or character or double or Boolean, okay, or any other user-defined type or any class type, okay. And generally we put it as private. So the keyword private means only accessible within class itself. So that's its visibility. Or we call this like visibility scope. The visibility scope, okay, it's private means only within the class itself. That's for the private, okay. And if it's public, then accessible is within and outside. So the visibility is both within the class and outside of the class. And for the instance method, you definitely need to give the return type. Okay, then the name of the instance method and the list of the parameters. And over here, so this is new, okay, and it's public visibility. And if you take another close look, you will find for this specific instance method, the name is going to be the same as the class name. Okay, so this is going to be new. And the parameter list is also optional. Okay, so this we call it a constructor. So later on, we are going to learn the concept. It's a new type of method called constructor. Okay, then further on, like over here explained. So instance variable, previously we already defined it's for attributes of the class. So it's very important. And generally speaking, we let its visibility be private. Okay, and the constructor, what it does do. So it's purpose is its goal is to initialize the instance variable. So it initialize an object's attributes. Okay. And instance methods. So it will do something on the class's instance variables. Okay, so it can either like retrieve attributes of a class. We supposed to see an object. Okay. Later on, we will see the difference between these two. Okay, or you can change or modify the attributes. Okay, so that's what the instance method generally do. Okay, previously I already explained about the difference between private and public. So it's about the attributes and and behaviors. So basically, instance variables and instance methods is accessibility, or we call it visibility. Okay, so the difference is private only to the class itself. Okay, public it's within class or outside of the class. And so previously we also mentioned is it the definition of class. Class is blueprint of a category of objects. So here we have the concept object. So class doesn't physically exist, but object physically exist. Exist. Okay, because it's a physical exist, so in programming language, we say physical exist means it takes memory, either on stack or heap. Okay, previously we learned. Uh, so this book is about OOP. So what is OOP? OOP is object-oriented programming. Okay, so here the first word is object. So now we see, so basically class is kind of a key component in this whole object-oriented programming concept. So it's objects, okay, objects. So something physically exists on computers' memory, either stack or heap, okay. And in OOP, there are some pillars. OOP has some killer components. One of the important is encapsulation. So this is a key term for OOP, encapsulation. So what is encapsulation? The encapsulation is related with the accessibility or visibility private. Okay, private. And previously we explained private, the visibility is to, so for instance variable for attributes, only accessible within the class. So only accessible within class. outsides doesn't allow accessible or visibility even. Okay. So for object-oriented programming, the concept for encapsulation is we try to protect attributes of object. So how to protect is we keep their accessibility within the class itself. Okay. And later on, but we will see sometimes you do need to access the visibility. Okay. So how do we do that though? So we have some approach to get around. Okay. So the concept for encapsulation is do not let outside directly access. So the application designer control the level for the accessibility and the visibility. So, and how do we achieve this? Through the keyword private. Okay, so this is a very important concept in OOP. So encapsulation. So encapsulation, how do we achieve it? Through the keyword private. Private is as a class designer, then you control the accessibility or visibility of attributes, and sometimes also including the behaviors. Okay. And this concept, you can also kind of understand it, like suppose your house, okay? So your house, you want some privacy inside your house. Is it suppose certain furniture, like suppose like your bed, okay? You don't want outward to view it as it so you want to have privacy, okay? But maybe some furniture, for example, like a Christmas tree, is it a Christmas tree and decorated with a Christmas light, then sometimes you do want it, other people maybe see it, is it? So then in that case, then uh, you can provide a window that and put your Christmas tree just by the window, and you open the blinds and or the curtain, and then the outside can see the beautiful Christmas tree. But for your bed, you want privacy, so you protect it. You even don't open the blind or the curtain to let the outside world to view it. Okay, so that's kind of the concept about the encapsulation. So you as a house owner, then you can control what do you want your furniture or other stuff in your house be exposed or even accessed outside of your house. Okay, and so in programming language, when we design a class, so how do we go ahead to proceed? Is it generally speaking, we start with UML class diagram, okay? So UML is a universal markup language. Yeah, so it is quite helpful. When you design a class, you start with UML class diagram, okay? And to design the UML class diagram for class, the general framework is you provide the name of the class, and so the UML is like within a diagram. So you have the name of the class, three parts, okay. And the second part, you include all of the attributes, so of the instance variables. Okay, later on we will also see you may also include some class variable. And so you put the name and then colon and the data type. Okay, and here before it, you need to determine the accessibility or visibility. So using plus, plus means public, and minus means private. So do you want to encapsulate or not? Or not? Okay. So if you do want to encapsulate, then using the minus, okay, means private. And the third component in this diagram is the list of the instance method or class method. So you list the name and then following by the parameter list if you do have, and then colon and the return type. Okay. So similar. For instance method, you also need to determine the accessibility, or we call it visibility, using plus or minus. Okay, so that means you want to encapsulate it or not. Okay, and then the body of the method, or that's regarding implementation. Okay, so this is just kind of you design you have a picture of your class. Okay, that's not implementation. That's going to be very helpful because later on, when we discuss application using object-oriented programming, there are complex relationship, not just about single object. It involves multiple different classes, is it, and their relationship. And so if before you go to coding, you have this UML diagram to sketch your class and figure out the instance method and instance variable and the relationship among different classes. So it will be very helpful when you go to the real coding. Okay, so here let's take a look at an example. Okay, so in this chapter, the first example, Java coding example is about a person class design. Okay, so a very simple one. So for this person class, then the UML diagram for this person class it's just like that you give the name of the class. And then over here, it's about attributes, or we call it instance variables. So we have the name, oh, the type is string, age, type is primitive integer, weight, type is primitive double, height is primitive double, okay? And they are all designed as private. Okay, so they are encapsulated. And the second part is behaviors. Behaviors is instance methods. and they are all public. Okay, so here the first two we see they are the same name as the class name, so they are called constructors of the class. Okay, then we have a set of method. If you take a look, the name always start with get something, okay, and following by the attributes, is it? So later on we will see they are called accessors or get method for class. And following that, we have the method you see for name, person, is it? So, but always start with set. So this group of method, we call them mutators, all set methods. Set methods, okay. And we have some other methods that's perform certain functionality based on our design, okay. Like the toString later, we will also learn that basically this is a method that inherited from the super parent class object. So in section one, when we discuss the class definition regarding instance method, we discuss there is a method called constructor type. That's new, okay? So what is a constructor? Constructor basically it's also instance method. Okay, so the purpose is to do what? Is to initialize the attributes of uh, instance variables, initialize the attributes of the class. Okay, so basically it's initialize the instance variables with values. That's the constructor, okay? Because just think about it, okay? Any object, if it doesn't have any value, that object couldn't exist. Yes? So you do need to create, whenever you create an object, basically you need to assign some values to its attributes, okay? Um, So the feature for constructor, it's a little bit different from other instance method is it must have the same name as the class name. So that's its name definition. Okay. And also it doesn't have return type. So if you take a look at previously in our UML diagram, it doesn't have return type. Okay. But all other methods must have return type. So no return. And there's another core feature for constructor is must be public. It cannot be set as private. Okay. So that's the definition for constructor. Very important. Just keep this in mind. Any class definition must have constructor. And generally speaking, for constructor, we have constructor without a parameter. So with construct doesn't have return type. Okay, so that's we already know. But regarding parameter list, it's not mandatory that you must provide the parameter. So it can be without a parameter, and we call them like a default constructor. If it doesn't have parameter, because the constructor used to provide initial values to instance variables. Then how do we do that? Is it because if you don't provide, is it then through the parameter? If you don't provide through parameter, then you can assign the default values. So you assign default values. So you determine, okay. And with parameter, so the second type is with parameter, or we call explicit value constructor. Then it does have parameter. So if it has a parameter, then you assign using the respective values from the parameter. So that's the difference between these two type of constructor. So now we come to another very important concept is about class and object. What's the difference between these two? Okay. And as previously I explained about the concept of OOP, okay, object-oriented programming. So the first word is regarding object, but where does the object come from? Object come from class, and class is blueprint. Object is physical existence. Because it's a physical existence, is that it's either on stack memory or on heap. Generally speaking, not stack. It's because whenever you create object, you always need to use new, and with new, it's always on the heap memory. Okay, so object exists on heap memory. Okay, so from the previous section 1 discussion, we understand the concept about class. So it's blueprint for category of objects. So they share, that group of objects share the common attributes and behaviors. Okay, but there is no physical. So no physical entity. Okay, object that's different. We also call it an instance of the class. So whenever we mention object, there is another close related term is the object or instance. Okay, so it's an instance of the object. So there is a physical entity, and because of the physical entity, so you can examine it, you can also manipulate it, okay, do some change. And in Java, normally when we do coding, okay, so class, so you have some library, is it? And so far we already learned, is that like a different kind of Java library. So normally class defined within the library, okay, and so that's still part of the blueprint. But when you really want to work with the class, you need to create objects. Okay, so when we create objects, normally the application, so we call it application program. Okay, application program, we also call it a driver file. Okay, a driver file, it's in Java, it's the main method. Okay, so you create objects in main method. And then the main method, because the main method is the entry point of an application. Okay, so in the entry point of the application, in the main program, then you create objects. So generally speaking, we call it like client program or driver. Uh, so just like previously we explained, is it about the concept, the difference between class and the object, is it? And because object's a physical entity, any physical exists, so it must reside somewhere or be created somewhere, is it? So that's created, like in this diagram shows our heap memory. Okay, so like for that person, is it? So we created a heap memory. Okay, so here in this diagram it also shows. So when we create, we use what to create? You call constructor to create. Okay, so basically you do something like over here, that person is a class, is it? So in main, you call the constructor, is it? So what the constructor does, basically this is a default constructor. And P1 is a person, a type. So it's our user-defined class type, is P1. And then you call the constructor, in this case, a default constructor. What does default constructor do is provide default values to instance variables like the name, age, height, and weight. This assign the individual values. And we can also see like integer value, double value, okay? And for the name, it's a string, okay? So it's created in its own, like the heap cell, okay? So this object then is created on heap memory with the invoking of constructor, or we call it call constructor. For section 3, so we will discuss in a later video session. So today let's just stop here.